Hello, this is the Blast Report podcast on all things blasting. My name is Thibaud with New Wave Consulting, and I want to thank all the drill and blast teams along with those supporting them who are out there on the pattern. The production team at Blast Think and I would like to welcome you to today's episode of the Blast Report podcast. This is the Blast Report, and we've got Tom Palangio here, and we're gonna I really want to hear kind of your story on how you got in the industry.
Okay.
You can look at your past record is very impressive, but what really kind of got you into the explosive industry at first? It's really, really nice, starting out at DuPont, right?
Yeah. It's, well, as you know, you can follow in the explosive industry for a while, and you'll find that most of the people, once you're in it, you can't get out. It's like the mafia. And it's a lot of good people from a lot of different areas. And
you don't get the bullet in the back of the head,
No.
Take the what is it? Take the cannoli. Leave the gun. Take the cannoli.
Yeah. No. I studied architecture, and sort of came at it like that. And then I worked for a couple of different outfits, government type outfits, Central Mortgage and Housing, and then I worked for a hydroelectric utility for a while. And then I had an opportunity to get a job with DuPont in North Bay at Nipissing Works. And we were making all kinds of explosives, nitroglycerin-based blasting agents, water gels, the whole 9 yards.
They were the king. Right?
Yeah. There was basically in Canada. It was DuPont and CIL. They were the king, and a real great company to work for. DuPont was an innovation company, and probably so far ahead of its time in terms of how they treated employees and everything else. So it was a really great company to work for.
But how did you? What made you go from architecture into I want to work with DuPont and chemicals of explosives? Was it?
Well, my architectural background, they wanted they were building facilities, and they were renovating and remodeling existing, and you get into a design group, you're called upon to do all kinds of things. And it wasn't only architectural stuff, but there was a lot of mechanical engineering stuff. But when you study architecture, you get into strength of materials, and you get into structures, and loads, and all the rest of it, which really serves you well when you get in the explosives industry, because you're dealing with wind loads and seismic effects and all kinds of other things. So, but you kind of eased into it. I worked in that design group for a while, and then I switched over to a division called Field Operations, where we had bulk sites throughout Canada, and right from coast to coast. And these are sites where you actually manufacture explosives on site and pump them. But again, every time you get a contract for that, you have to build a bulk site, and you have to go through all of that.
And this was starting with the prior to the emulsion, and we're talking with the AN solution all the way to the entire creation.
Yeah.
Okay. Yeah.
Most of the bulk sites were water gels, and it was some handful, but not that much. But major customers, that like in the coal fields were cast blasting. It was really a good learning experience. You got to travel a lot across the country. You got to, work in various various operating conditions and that. So it was never a dull moment. And I worked there for quite a while, and then I had an opportunity. There were some changes going on, and I got into a technical service group. And well, actually, I missed a step there. Whenever we would need to do something, like maybe we had to use explosives ourselves, we always had to bring in a local contractor or something like that. And I suppose I took the initiative and I decided to get my own blaster's license.
Oh, that's first mistake right there.
It was good for me because, I went to the Ministry of Labor and I wrote all the exams and everything else. I think I was the only one within the DuPont organization that actually had a blasting license.
Wow.
I mean, just because you make explosives doesn't mean to say you know how to use them or anything.
Absolutely. It's absolutely true.
So as soon as I had that, at the time there was maybe a sensitive job or something we needed to do ourselves, then I was the one to do it. And then I ended up in what they call a technical services group. And actually our boss was in Wilmington, Delaware. So, I mean, this was DuPont's main headquarters, and that gave me access to pretty well all of North America. So it was interesting. And the people at Wilmington, a real good bunch, and some of them were absolutely brilliant. I mean, there were people there that worked on the Manhattan Project. And
wow.
Just to work with them was a real treat, learned so much. And some of the kind of giants in the industry, I think I recall, like, now the names I'm getting blank, but Al Andrews was one of them, and Klaus Rucker, and it just went on, but each of them had a specific
expertise.
Yeah, that was, it was neat. So I learned a lot, and
you had an opportunity to travel and see explosives in all these different applications as well, right?
Well, and because I was the sort of practical field guy. Mm-hmm. If they were developing a product, like I remember they were developing a product for trenching. And trenching can be quite fussy because you're confined and everything else. And,
absolutely.
And so I remember going and troubleshooting those applications and making sure they were doing it right and stuff like that. And so that's where, again, my expertise came in and my experience and everything else. So it was good.
But with trenching, that is a very demanding, because not only is it fast pace, but the rock in one hole 5 feet over is not the same in the next hole. The conditions are absolutely insane all the way across the country.
Well, in many cases too, you're quite close to built-up residential areas. In fact, you could be in a subdivision. And you want to minimize any adverse effects, and yet you want to be able to pull the bottom in one shot without, and in many cases we like to leave the overburden intact, just the muffled noise and fly rock and everything else. And so sometimes you really, you're hoping that the hole's where it's supposed to be, where it's going, where it's supposed to be. So.
And the movie with Kevin Bacon, that was, I'm blanking on the movie here, Tremors.
Oh, yes.
That was made, right? Those Tremors were made with trench-style blasting. Yeah. A lot of people don't know that. They all love that movie, but they didn't realize that some of that is venting. Yeah. Some of the hole you can see in the movies.
It's really neat when you initiate a shot like that to see how it's going. The explosives in those applications have to be quite rugged and withstand high shock and pressure. You're going to get failures, and so it was neat. And these are the days too where we didn't have the fancy digital detonators that we have now. It was it was electric, and there was a certain amount of scatters. you couldn't shoot it as fast as you really wanted to because of overlap. And, so anyway, lots of challenges and lots of experience along those lines. So
did when you came into that industry and you saw how the variables were constantly changing in explosives, did that intrigue you? Did that add to some of the interest? For me, I think that's something that I really enjoy about the industry is, no rock is the same, and you can have this a blaster, operate this one quarry, and they've got 40 years of blasting experience at this quarry, and you ask them a question, and to your eye it looks like very uniform rock, and then they can say, it's an art form, trying to work with that rock. And then you have blasters in construction who are just never in this, they're not even in the same rock at one day, right? They're constantly changing. So is that something that you really enjoyed? Was that, or is that something you kind of?
Yeah, well, those are some of the unknown variables, or at least sometimes they're unknown. The geology, yes, has a big effect on the outcome. And so and actually that leads us into a couple other things. DuPont was one of the innovators in that they acquired a blast model. It was called BLASPA, and it was introduced by a fellow from the Royal Military College called Dr. Favreau. And I think at the time, and this was fantastic for those days, they actually paid $1 million for that BLASPA program. And so they were looking for a way to actually determine what the outcomes would be before you shot. And they were looking for a way to actually validate the model. Because, there's various thermodynamic programs and stuff like that. If you know how much energy you're putting in and rock characteristics, that you can kind of predict an outcome. Mm-hmm. But at the time, it was very theoretical. How are you going to validate that? Yeah, all the professors, everybody says it'll work, but in the field, will it actually work? So I kind of got involved with that. There's a saying, you have to be able to measure something before you can really manage it.
Right.
And how do you measure the results of a blast? I've been on shots, we load it up and it goes boom and everybody kicks a few rocks and says, what do you think? Oh yeah, it looks okay, but these are just adjectives. What the hell?
Absolutely.
A shot that you think is good, I might think is really poor.
You're absolutely right.
It depends on our background, and everything else. And so it became obvious to me, and I'm sure everybody else, that we needed a way to quantify blast results. It's meaningful if you say, 60% of the material is under 3-inch. That means the same to you and me and everyone else. But these adjectives like poor, fine, or good mean absolutely nothing.
Does it dig? Usually diggable. I like how we put a bull at the end of ability, blast ability, dig ability. I love that when I got into the industry, learning all the terms like that.
We actually did in St. Louis. I think we actually designed a blast, we shot it, and we sieved the whole blast.
Wow!
Imagine. I think it took 3.5 weeks. And
wow!
But we sieved it. We knew every particle generated in that, what screen it would pass through.
But that is an insane level of detail.
It's nuts. Like nobody could, that's
takes deep pockets.
It's never been repeated. Yeah, and DuPont, like I say, put that money into research to be able to validate things, and it led me into a way where I knew that the University of Waterloo in Canada had developed a system for doing measurements based upon imagery. And I thought, well, it might have some potential. So I got in touch with a fellow by the name of Dr. John Franklin. And what Waterloo did was they were taking pictures, even satellite imagery, of the ground. And by enhancing the image, we're actually able to determine things like underground aquifers, jointing, all kinds of stuff that we wouldn't ordinarily be able to see.
This is like LiDAR imaging or just actual
It was just
satellite?
They used a lot of the spectrum, like everything when it's exposed to light gives off a certain spectral response. And when I approached him, I thought, maybe is there some way we can use imaging instead of sieving or counting or doing something, because it's a lot easier to measure than it is
with the shovel.
And he had an undergraduate student, Norbert Mertz, and that's Dr. Norbert Mertz now, and he actually was a university professor in Missouri afterwards. But he came up with this idea and way of using imagery to measure particle size. And he used what they call WEEP, which is the Waterloo Image Enhancement Project, or process, WIEP. And when we tested it for measuring blast fragmentation, we shortened it. We called it WipFrag.
WipFrag.
So it would be the Waterloo Image Process Fragmentation Analysis Program. And with that, we would take, and these are the days when we didn't have digital cameras, right?
Right.
You'd take a picture and you'd print it, and you'd put it on a copy stand. And you'd have another camera that would look at the image, and it would define the edges of each and every particle that was in the image. And then you'd go through various algorithms, and you'd get the size and the shape and everything else, and you'd end up with the result. And it was sure as hell wasn't instant like it is today, but it sure was a lot easier than bombing tons and tons of material,
Absolutely.
And it wasn't perfect by any means. In fact, a lot of manual editing was required.
Even when I got into the industry, I would use the color mustard. That was the color that I would delineate when I would check, because it was the least offensive on my eyes after hours of drawing Etch-a-Sketch. That was I remember that very, very well. So you would have to do this inside the software not on digital.
Yeah. So that was a big advancement. And when you're selling explosives and when you're servicing a client, it's really nice to be able to benchmark when you first arrive, to see what they're getting now, and to actually introduce them to a design and a pattern and a sequence and a product that'll enhance or improve what they're doing. And our motto is, you can't manage what you can't measure. And if you can show a client improvement, it goes a long way. And it actually points out if you're having a product application problem, maybe you're using the wrong explosives for the particular
Absolutely.
Right away. And so that
you can really settle a lot of arguments between blasters on the bench too. Oh no, the stemming shouldn't be like that,
Like these were the days when real large accounts would actually invite different explosive manufacturers to come in and have a test shot. And I remember going to shootouts all over North America, where maybe Atlas would be there, DuPont would be there, Austin would be there. Like all of the major explosive manufacturers would be shooting.
And you would go and watch them? So it was like a big show.
Well, and
Oh, that would be kind of fun.
the cast blast I was on it was unbelievable. Down in San Juan, New Mexico, there was a big shootout there one time. I was down there with high-speed cameras and everything else to measure the cast. It wasn't just fragmentation; it was the cast and everything. But that's how you won or lost contracts based on your performance, which was it was a change in the industry, because before that it was cost. Oh well, it's your info's cheaper, so buy it. But you know what? Sometimes the low cost product isn't the best. So.
And now you could quantify that.
Yeah.
I always hear the term downstream. It's downstream, right? And I remember one of my first jobs, the mine site would not provide with quality stemming. They didn't want to dilute the ore, and so they filled it with cuttings. And every single shot, you just watched energy fly into the sky, and you're just seeing all of this wasted energy.
Yeah.
And, when it comes down to utilizing new technology, you could prove to them that they're wasting. This is just direct waste going into the sky. And there was no way to justify it before. And you just, like you said, you have to give them numbers and monetize it in order to do that. And so when it came to convincing people of this technology, was that an interesting subject that you had to, not everyone is always open to new technology, right? There's slow change. Was there some sort of tricks that you would do other than just with data to convince people to adopt this new technology? We're always talking about adoption curves and what would sell people on this, or they would think you're just coming in feeding some new technology that costs too much money.
It depends. It depended on the sophistication of the client. Some of them looked at the whole process as being pretty simplistic. If you're a construction contractor or something like that, maybe as long as you can get the rock out safely and effectively, that's it. That's the end of the game. But particularly when we get involved with mining clients and stuff like that have to, the blasting is just the first part of the comminution process. And you'll get that material out. Explosives, because of their shock value and everything, are the most efficient way yet to, reduce the size of rock. But if you don't blast it well, then your material handling costs go up. The maintenance on your loaders and everything go up. The crushers and the grinding and the milling, if you're in the mining process, they all go up. And so, if you just look at the drilling and blasting, it can give you a false economy. Oh, you might save a couple holes and some accessories and some explosives. But when you pass that material downstream, you're just paying all kinds of money that you didn't have to if you would have blasted properly in the beginning.
Mm-hmm.
And when you look at that as not just a bunch of discrete steps, but when you look at the mining process as a whole thing, I can save people. In fact, I've went into places and I've tried to sell the technology, and they say, "Oh, that's pretty expensive." And I'll tell you what, I've told a couple. I said, "I'll give it to you for nothing. I'll put the cameras in here. I'll do all that type of stuff, and it won't cost you a cent. But I want 5% of your savings for a year." And when they start to do the math, they say, no, we'll buy one. Because it's unbelievable. Your maintenance costs, your energy consumption, those types of throughputs, what do we do?
I love that. It's a very good method.
Yeah. But without numbers to work with. And that was That was our motto too. You can't manage what you can't measure.
Mm-hmm.
Dang, where you go.
It would be, to sell it like that and to build a contract based off that, I would think would be kind of hard with all the different variables. But that at that point, they start to really think about what actually is the price of it, and if you can.
Yeah. Well, and I kind of got a little ahead of myself too, because I stayed with DuPont until I think it was 1990. And then I decided things were starting to change in the explosives industry quite a bit. There was mergers and DuPont become Explosive Technologies International, or ETI.
Mm-hmm.
And lots of changes going on and everything else. And I thought, with the knowledge I have now, the expertise and everything else, I'd like to start my own explosives consulting business.
Congratulations. That's a big step.
And I wasn't sure how successful I'd be with that. So I actually went to my buddies then at Waterloo, and I said to John Franklin and Norbert Mertz, let's form a company and market WipWare. And they said, okay, we put together a company. We went. I also had a contract. Put it this way, when I worked with DuPont, I was either part of, or I had quite a few patents, my name on them, and they belonged to DuPont. But I think they were a little concerned that I might leave and work for a competitor or something like that. So I signed an agreement saying that I wouldn't work in the explosives industry in North America for 3 years. And so that was good. And so where did I go? I went to Panama.
Wow.
I'm just outside North America.
Mm-hmm.
And the U.S. Army Corps of Engineers is widening the Panama Canal. And they're having some problems. Not big problems, but minor issues. And it's with explosive products they're using. They're using, commercial blasting agents. And the problems involve things like they're not being able to get the depth they want in parts of the canal.
Mm-hmm.
And the cruise ships were going through and they were getting oxides of nitrogen. And some of the people on the ships were feeling nauseous. And almost every cruise ship in the world is white. But once you go through that, you might be more like orange or brown.
Oh, really?
Staining,
Yeah.
And it's a bit of a problem. It was an interesting job because they really did it right. And, they had to get all kinds of snakes and are they crocodiles or alligators? I know one of the two, anything out in there. And the area had been used for many years as a test site for aircraft, so that they had dropped all kinds of munitions through there.
Through your drill patterns, essentially.
Well, through the hills and stuff like that we were taking out. So that was interesting on its own. They had to get people side by side going through with metal detectors to find this stuff before we get in there and start drilling and blasting and doing various things. So it was an interesting job. And I was actually working with an old friend of mine too, who's no stranger to the explosives industry, Frank Geppetta, with Blasting Analysis International. And after that, I went to Peru, and I did some work for ENEX. No, EXA. I did work for EXA. And some of those Peruvian jobs, copper, really, really big mines and good people. And again, helped them with the blasting and applications. And after that, I went to Chile, and I worked with NX and helped them in a whole bunch of different jobs. When you work as a consultant, you're kind of a free agent.
Mm-hmm.
Sometimes those companies need an outside set of eyes to come in and just see what they're doing. And just because the design, says that the pattern is this, you have to go on the bench. You have to measure it yourself. You have to make sure that they're priming it properly. You have to make sure they're using adequate stemming. All of the variables.
Absolutely.
And
it's crucial.
It's hard for locals maybe to do it or to have the same perspective as an outside set of eyes comes in and says, hey, why are you doing that? Yeah, everybody has their own way of doing stuff, but you have to ask yourself why, And then I actually went to South Africa, and I did some work for SAMSSA. And then after that, I went to Australia, and I did work at Hammersley Iron and a few other places. And by that time, the 3 years was up.
Okay.
Okay.
So the green light, you got the green light now.
I got the green light now. But by that time, I actually, not only was I selling my consulting expertise, but I was selling wood frag. I was selling the technique, the measurements, the equipment, everything to take pictures, analyze them yourself, and do that type of stuff. But it was funny because I actually had an international distribution network, but I had no domestic business because I hadn't been allowed to work,
Mm-hmm.
which is really, it's back assward.
It sure is, yeah. To go international first.
Yeah. And so that gave me a unique perspective on it. And actually, I like to help domestic producers that want to break into foreign markets, because I know how to do that. I did that first.
Yeah.
And you develop relationships, and it's good. I really love the explosives industry, and it's been good to me, and I hope I've been kind of helpful.
Oh, absolutely.
For a lot of people that are moving on.
Well, I've personally seen you support small businesses and not just younger people in the industry, but you can really tell what your company and what you and Thomas have done for people. It's a lot of support, and we thank you for that. Thank you for that. And
well, it's a labor of love. So many good people in this industry, and I think I've been a member of the ISE for probably, it's getting close to 40 years. In fact, when I joined, it wasn't the ISE, it was the SEE. It was an international yet. And it's a long time to be coming.
Well, we are really lucky because today it's your birthday.
Today's my birthday, imagine that.
So happy birthday, and thank you very much for coming on, and some more years in the explosives industry, and hopefully we can you can keep with a smile. Thank you for listening to this episode of the Blast Report podcast. I want to thank the team at Blast Think for producing this show, and please follow along for more episodes in the future, and share this podcast with your colleagues so we can continue to honor our industry and the people in it. Be safe and have a blast.